For this particular problem, what we wanted to do is, or what was asked of me was to show how you go from 4 cosine squared x and find the antiderivative of that to get down to here. So what I'm going to do is I'm going to use a trig identity that you're very much aware of. So we need to get this red part here. So what I want to do, what was at least asked of me, was to do the following. To take and determine the integral of 4 cosine squared x dx. That's right here, and that's this red piece that's highlighted. Okay, so how am I going to do that? Well, so here's the thing. I don't know what this guy is, and if I try to do a substitution here, I'm going to have an issue, right? So if I say let's let u be equal to cosine x, well, that's great. Now we have the integral of 4u squared dx. So I got to get rid of this dx. Well, how I get rid of it is by substituting here. So du is equal to negative sine x dx. So that means that dx would be equal to du over negative sine x. See, but now this has got to replace this guy, and now I end up with another sign in there. It's an ugly mess. So what we're going to do is we're going to take a look to see how we might be able to substitute just this piece here. So what I have is the following substitution. So I'm going to pull up just a list here. So let's go to Google and we'll find trig identities. Okay, so there's a whole bunch of them here. And what I'm looking for is a cosine squared of any of them. Okay, and if I scroll down, oops, you'll see right here I have a cosine squared. So I'm going to go ahead and grab that guy. So we're going to use this guy right here. So cosine squared u is equal to this, which means I can replace this with the integral. I'm going to pull this, so we're going from here now. I'm going to pull this 4 out. Cosine squared x dx, which by this over here I've got 4 times the integral of 1 plus cosine of 2x over 2 dx. So if cosine squared x is then equal to 1 plus cosine of 2x over 2. So I got this. Okay, well now I'm going to pull this half out, so the 4 divided by 2 is just 2. So this is 2 times the integral of 1 plus cosine 2x dx. Remember, the dx applies to the whole thing. So now we can split this up. So this is 2 times the integral of 1 dx, which is just dx, plus 2 times the integral of cosine 2x dx. But now I got this 2x in here, so here's where I'm going to make my substitution. I'm going to say let's let u be equal to 2x. That means that du is equal to 2 dx, or du over 2 is equal to dx. So let's do some replacing in here. So this stays the same. I get this. Now, this is going to be cosine of u, because u was 2x. Now dx is equal to du over 2. That. So now I'm going to pull this 2 out, so this 2 and this 2 cancel, so I get 2 times the integral of dx plus the integral of cosine u du. Okay, now this guy right here is pretty easy. This is just 2x plus the constant of integration. We'll call it c1. I know we're going to evaluate over here in a second, okay? So we won't need this constant. You know what? It's irrelevant. So we'll take it out. Now, the antiderivative of cosine, well, where does cosine come from? It comes from sine. So this is going to be sine u. But u was 2x. So this is 2x plus the sine of 2x. And if I factor out a 2, that'll be 2 times the quantity x plus sine 2x over 2. And that is where that guy right there comes from.